Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. My name is Kamarul Al-Hafiz bin Abdul Razak, participant from University Science Malaysia, Engineer Campus Penang. So today I would like to present about my topic, which is design of fixtures for single incremental forming process based on design for assembly methods. Okay, this is the abstract of this paper, which is we try to discuss the application of a DFA method by Boothroyd Dewhurst to select the best design of a fixture, especially for a single point incremental forming process. For the first step, we have to design the fixtures using SOLIDWORKS software, and we try to focus the manual handling and insertion of the fixtures by reducing the number of parts and compare the both of the fixtures. So the chosen has been made based on the best design efficiency, and at the end of the analysis, we can say that the result found the application of a DFA improved the design efficiency, which is the welded base on design fixture B is 35.62% is greater than the design efficiency of fastener-based design fixtures A, which is the design efficiency is 23.04%. Sheet metal forming is one of the most popular process in manufacturing industry. Due to the high flexibility in demands, industry nowadays more focused on the design customization, low cost, complex geometry, and the most important things is about the quality of the finished part. One of the processes can meet all these criteria is incremental sheet forming. Frequently, the ISF process can be determined based on the size of the fixture and the geometry of the part. Typically, the fixture consists of the top plate and base plate by clamp the sheet by series of threaded fasteners. Incremental sheet forming process can be divided by two types, which is the first one is a single point incremental forming, and the second one is a 2-point incremental forming. The figures one show the SPIF process. The advantages of SPIF, which is the single point incremental forming, is a dieless process compared than the 2-point incremental forming, and the single point incremental forming is more flexible and less tooling cost. So the working principle in single point incremental forming is a forming tool will move controlled by a CNC machine or robot arm. Then the forming tool will push downward incrementally the clamp sheet metal, and the process is continued until the final profile is obtained. Fixture design requirements require interchangeable and repeatable processes to produce a same part but maintain the process position. The purpose of this fixture is to ensure the mounting of the workpiece is curable during the process and support to produce high accuracy for the finished part. So figure 2 shows the example of design features. So element of features consists of several elements, which is the first one, the yellow ones is a locator, the green one is about the clamps, the purple one is a supporter of the fixtures, and the fourth one, which is the main one, is about the fixture body that use aluminum profile. In the methodology section, I will explain about the process sequence. The first one, create the 3D CAD design using a SolidWorks software. I'm using a SolidWorks version 2016. The second step is determine the total parts of both design fixture. The third one, determine the theoretical minimum numbers of both design fixtures, followed by calculate the operation time of both design fixtures, and that's the last one, calculate the design efficiency of both design fixture. So the figure 3 is show the design fixtures A, and the figure 4 show the design fixture B. This is the expert drawing for a design fixture A that consists of 6 different types, which is they have a frame, layer, cover, toggle clamp, tighten, and bracket. So total quantity to develop design fixture A is about the 40. Table 1 show the total parts of a design fixture A. Then table 2 is theoretical minimum number of a design feature A. So by using data from table 1, which is the part number, name and quantity, then the next step we try to um, evaluating the part list to obtain the theoretical minimum number by mark 1 for essential part and 0 for non-essential part. In this list, the all parts we put the essential part except the Titan, the part number 5, because since we already have the toggle clamp as a clamping device, so we try to reduce the another clamping device, which is we try to eliminate the Titan as a non-essential part uh, for a theoretical minimum number of design feature A. So the total theoretical minimum number of design feature A are 36. This is the exploded drawing for a design feature B that consists of 5 different parts, which is a frame A, frame B, frame C, base and a G clamp. So a total quantity to develop design feature B is just 70. So table 3 show the total parts of a design feature B. Table 4 show the theoretical minimum number of a design feature B. Same like design feature A, we try to find the theoretical minimum numbers, but for a design feature B, we try to remain the all quantity and all parts because they got their own um, criteria, and also the we have already optimum number of this feature. So the theoretical minimum number of design feature B are still 70. Same like numbers of the total parts of design feature B. In this stage, we have to determine the operation time and design efficiency of a design feature A. Table 5 show the assembly time of a design feature A, which is consists of several information, alpha, beta, alpha plus beta, handling code, handling times in second, insertion code, insertion time in second, then total operating time in second. So how to find the value, because we need to know the alpha and beta orientation first to substitute the value. So the alpha and beta orientation method I already attached at the end of this slide as a reference. Same like handling code, handling time, insertion code and insertion time can refer the standard codes from a manual handling classification and also manual inserting classification table that I already put at the reference as well. So the design efficiency can be calculated from this formula, which is a 3s time of nm. Nm stands for theoretical minimum numbers of a design feature A, and tm is a total operation time of a design feature A. So based on this formula, we can find the value of a design efficiency by design feature A is 23.04%. Same like design feature A, for design feature B, we also need to determine the operation time and design efficiency. So table 6 show the assembly time for a design feature B. So here also have a information about the alpha, beta, handling code, handling time, insertion code, and insertion time. So also based on the reference, we can find the value of the alpha and beta, handling code, handling time, insertion code, and insertion times, so that we can calculate the total operation time. So based on the design efficiency formula, we can find the value uh, of design efficiency of design feature B is about 35.92%, greater than a design feature A. Table 7 show a comparison data between a design feature A and a design feature B. So we can say that a total part of a design feature A is greater than a design feature B. The total operation time to develop design feature A also higher than a design feature B, and the design efficiency for a design fixture A is less than a design fixture B for a design efficiency. So as a conclusion, we can say that the study of a design for an assembly is very useful in order to achieve the best design by focusing in a manual handling and insertion method. The design efficiency value is very significant in order to achieve the objectives of the research. The results show the relationship between the total operation time is inverse proportional with the design efficiency, which means low total operation time will increase the design efficiency. Selection, codes on manual handling and insertion charts also may affect the result. Even the value of a design efficiency is not very high, but by compare between the two design feature, we can say that design feature B is better than design feature A.